Welcome to DABCC Radio,
where smart people listen.
Virtualization and Cloud Talk,
Featuring cutting-edge solutions from the hottest companies around the globe.
Broadcasting from the DABCC offices in sunny Sarasota, Florida.
Surrounded by computers, books, and Legos.
A Microsoft MVP, Citrix Charter CTP, VMware vExpert.
And your host, Douglas Brown.
Hello, everyone, and welcome to DABCC Radio. I'm Doug Brown, and I have a great show for you guys today. We have NGINX on with the line with us, and these guys make I'll let them describe what they make. They make a great solution for doing so much to your web applications that it's just difficult for me to even try to spit it out. So I won't do that. I'll leave it to my guest today. We have Liam with us. He's one of the product managers at NGINX, and been around the company for a while, and a very smart guy that knows this technology inside out. So we're going to have him share with you guys what this is, what it means to you, a little bit about some of the areas they've been moving into for quite some time now, Microservices and Docker. And, where does this fit? Why should you care? We should be thinking about what they're doing. And that's the goal for today. So with no further ado, here's my interview with Liam from NGINX. Okay, Liam, thank you so much for taking the time to be with us today. I look forward to this conversation. So I think we had NGINX on a long time ago, but I'm a fan of what you guys do. It's a big company. You guys do a lot of neat stuff, and so it's always fun to have you guys on. So thanks, first and foremost, thank you for taking the time to do this with us.
Pleasure.
Okie dokie. And as always, my first question is, who are you, and what do you do over at your respective company? So, Liam, who are you, and what do you do over at NGINX?
I'm Liam Crilly. I am Director of Product Management here at NGINX, and in my spare time, I like racing cars. So anything that makes the web or vehicles go fast, that's me.
Well, that sounds like a lot of fun. We can do a podcast on that. Forget the NGINX. Let's just talk about car racing.
You'll get me in trouble.
Yeah. Don't worry. We won't do it. Don't worry. I'm harmless. But that sounds like a lot of fun. I when I was a kid, I would race my car, but I get myself in trouble for doing that. Nowadays, I just keep the speed limit. I live in Old Personville, so anything above 35 miles per hour is a scary event for me. So,
well, this is strictly road racing, so I don't scare the neighbors too much.
Yeah, that's cool. That's good. That's good. Yeah, try not to do that. So, can you tell our listeners a bit about NGINX? What is the goal? Give us the 40,000-foot answer. Who is NGINX and why should we care?
So, NGINX at a super high level is a high-performance application delivery solution. Now, that boils down into we're a high-performance web server, we're a reverse proxy, we're a software load balancer, and we're a whole bunch of other stuff that makes web applications, that is, go fast, work reliably, and scale out to hyperscale. I mean, I guess the headline would be, the busier the website, the more likely it is to be running NGINX to help it scale.
Yeah, DABCC actually runs NGINX. So you guys help us, do some caching stuff, which is quite cool, and I absolutely love it. So,
it's almost like a little bit like a Swiss Army knife of HTTP. So, whether you need acceleration from caching, whether you need to handle huge amounts of concurrent connections, whether you just need to keep latency as low as possible and serve static assets from one place and dynamic content from somewhere else. Whatever the problem is that you need to solve to help your application get out there and perform, then there's very likely there is something in the NGINX toolkit that will help you get there.
Yeah, you got it. So you guys have been growing at a very rapid pace. I mean, NGINX is, you just said it. If you're doing anything on the web, there's probably something in NGINX inside. Can you talk a bit about this? Why is this?
So, you're right. We have been growing tremendously. The project itself is a lot older than most people think. We've had what our founder, Igor Sissoyev, would call a viable product since 2007. And we've been a commercial business. NGINX Inc. was formed in 2011. But the growth really from that point onwards has been terrific, to the point where, as I said, the busier the site, more likely it is it's running on NGINX. And the numbers bear that out. If you look at the top 1 million websites, 41% run NGINX. If you look at the top 100,000, it's over 50%. Wow. If you look at the top 10,000 busiest websites, then it's 60%. So the growth's been tremendous. We've had an upward trajectory for as long as I can remember. And why that is, I think it's partly to do with our history. So, this NGINX was created to solve a problem of handling a large number of concurrent connections on a single web server. And back then, a large number was 10,000. So Igor solved that, and we started as a high-performance web server that could handle all the static assets. Then reverse proxying became almost a ubiquitous use case. So you would put NGINX in front of the application, handle all the dirty internet-facing clients on, whatever speed link they've got, whatever dodgy browser, not necessarily standards compliant they've got, and then behave like a really nice, fast client to the application. Basically smooth all that stuff out. So the application spends less time waiting and more time just doing what it needs to do. And that became quite popular with operations folks who wanted to separate what functions were run on which back-end system. And as that became more and more popular, excuse my printer, as that became more and more popular, then the developers sort of hooked onto the ease of configuration, the small footprint, and the inherent efficiency of the software. And I think that combination has helped us just explode in recent years. So as independently, dev and ops got to like it, and DevOps was a natural fit. And that long-standing, rock-solid footprint that we have out there helped drive that even further. And then more recently, coming back to that inherent efficiency, we're very, very efficient on CPU and on memory, memory in particular, especially as that scales connections. We don't have a linear growth. And that means when it comes to deploying NGINX, you can stick it on a container, but more recently, things like Docker, and we're the number one resource on Docker Hub. That inherent efficiency and small footprint just fits the way of building modern applications. And so, in a way, just building it right first time has helped us stay current and stay relevant and be the default choice for how to deploy applications.
Perfect. So what do you do with the Docker stuff? That's interesting to me. How's that? How does NGINX fit in there?
So the nice thing is that we didn't do anything. The product just fits very nicely with containers and with microservices, where you want to compartmentalize everything, where you want to isolate services from one another and build things in a very discrete manner. And the fact that NGINX takes up hardly any memory, is very efficient on system resource utilization, means that there's almost no overhead in deploying NGINX alongside your application, whether that's your application and NGINX sitting in a container or on a huge bit of iron, then it works just as well. So where developers and operations guys have been used to deploying software in NGINX, when you transition that to experimenting with containers and microservices, then it just fits very nicely. Our inherent architecture means that they are natural bedfellows, if you like. So it's been painless for people to experiment with NGINX in and around Docker. And I think that's why it's become so popular as a Docker resource, and also why it's become a lot easier to build microservices when you don't have to have a very heavyweight application server sitting next door.
So when you say no overhead, what do you mean by that?
So to spin up NGINX on your container will take a few tens of kilobytes of memory. For each new connection that comes in, another few, say a kilobyte at most. And then as you start handling more and more concurrent traffic, you don't have to find huge amounts of memory. So it means that it's super efficient. You don't need to allocate any special resource to have NGINX perform.
You almost save more memory than you use, right? Is that true?
Yeah, you save more memory than you use compared to the alternative, for sure.
Yeah, that's how I see. Yeah, go ahead, please.
Explain a little about the NGINX architecture. So it's an event-driven architecture, which means that there's only one copy of the application running in memory. And when a new connection comes in, instead of having a separate copy of the application code, we essentially have one copy, and we have one big loop, and we go through that loop over and over and over. And every time there's a new connection, then we put a new connection into that loop, and we keep checking back to see if that connection is ready to be processed. Have we got all the requests from the client yet? And when we have, we can send it on to the back end. And when we've got all the response from the back end, then we can send it back. But whilst we're waiting for these things to be ready, we just go round and round the loop, handling whatever other connections are available. And that's why we don't use more memory per connection than it takes to handle the size of the request itself. And by that I mean, the URL and whatever headers come along with the client. So it takes very little memory, which means that we can scale to hundreds of thousands of connections per server, not way beyond the original goal of 10,000 connections.
Yeah, you got it. No, it's beautiful. At what point does a customer, look at something like NGINX? Should this be out the door, or there's a come a time in the life cycle of an application that you want to deploy a solution like this? When should they be looking at you guys?
Well, partly it depends on use case, but it also depends on maturity. So for many developers and DevOps guys, it's the go-to solution. So you start with it from day one because it's been around for a long time. People understand it. So that's the one side. On the other hand, if you're more of a large enterprise shop and you're used to deploying applications with your hardware load balance, your big pieces of iron rack mounted somewhere, and now you've migrated to the cloud, or you have an entirely virtual environment internally, and that model doesn't work anymore, then using NGINX as a software load balancer is something which gets introduced either at deployment or when scaling is required, when an application becomes mission critical and you need to have high availability, so you need to have multiple instances of your application available. And then, whether you call it an application delivery controller and ADC and in industry terms, or whether you just need a software load balancer to perform that function, then that's when NGINX often is introduced into an organization. And in particular, our commercial software of NGINX Plus is very much aimed at that software load balancer use case.
Makes sense. So as companies are moving their workloads into the cloud, we're seeing a lot more cloud applications. Is that an area where you guys are seeing increased use cases? I imagine so, right? You guys probably definitely power that future.
Yeah, very much so. And that's something that's been happening for a number of years now and shows no sign of slowing down. So, organizations moving their application infrastructure to the cloud, they already know they need a load balancer. They know they need something to sit in front of applications to protect them from badly behaving users or badly behaving clients or unreliable networks and unreliable, potentially unreliable backends. Sit there and be that consistent single point of entry for application and hand off requests to the endpoints, the backend. Now, they know they need that because they had that as a hardware load balancer in their environment. So when they move to cloud, it's one of the problems that needs solving. Now, NGINX and NGINX Plus were very much part of enabling those cloud migrations, especially when the applications are absolutely critical. So that's something that we've been doing for quite some time, and we have a product which helps with that, regardless of the cloud platform that you're looking at.
Perfect. I was going to ask you about, you just regardless of the cloud platform. So does it, AWS, Azure, things like that? Is there play there? How does that stuff work?
Yeah. So all of those. So you can find NGINX and NGINX Plus as an AMI on Amazon. You can find it on Azure. You'll find it on Google Cloud Platform. And although each of those platforms have a load balancer solution of some sort. I mean, I said how people know they need it. Regardless of it being a kind of a default platform provided load balancer, NGINX is increasingly popular, not only because people might already know of it and have used it in their internal environments, but also because if you want to have a cloud neutral strategy, if you want to have a multi-cloud strategy, then you want to have as much of that stack under your control as possible. So having a hybrid cloud solution where the load balancer is the same, regardless of whether it's on-prem or in your chosen cloud environment, is very attractive to the DevOps teams. It means that they can lift and shift an entire stack, load balancer included, from one environment to another. And that's where we have see a lot of discussions and a lot of customer interest and production use of exactly that kind of mode.
Makes sense. Makes total sense. So you talked a bit about the architecture a little bit ago. Maybe can you give us some more information around that, the techie side of things, and then what does it take to get up and running? I guess that depends upon if you're in the cloud or on-prem or things like that. But in general, can you sort of describe that in words? So
the architecture I mentioned, I think to get into the more technical side of things, NGINX is written entirely in C, not C++ or C# or anything else friendly. It's pure C. It's written. I had this comment from a conversation I had with it last week, who said, I've looked at the code and I love it. It's like assembler. And for some people that's great. For some people it's a bit off-putting. But it's a performance product, and it's written in C to go as fast as possible, to be as efficient as possible, to use only the resources it needs, and to get its job done as quickly as possible. And to help with that, we have, and which might be new to some of your listeners, is that we've recently adopted a far more modular architecture to the code itself. So it used to be that if you wanted to extend NGINX with additional modules, whether written by us or whether written by the community and the open source environment, then you would need to compile that module in. So to be the most efficient, you would have to you put your code next to our code and you build a version of NGINX that ran with the extensions that you needed. So we went a significant engineering and re-architecture process about 18 months ago, which allowed us to dynamically load modules. So you can now take the official build of NGINX if you want the one that's been through our internal QA process, or take our commercial product, and you can load in a module written by any of the open source community and have that load into the official NGINX build and run. So that's been in recent years one of the significant architectural changes in the underlying code. And that's enabled a whole bunch of use cases and made the extension to NGINX available to a great number of people, either because they weren't comfortable compiling it themselves, or because they wanted or were required to take an official build for other reasons.
And what does it take to get up and running then, too?
So yes, to get up and running. So I mentioned if you visit ngix.org, you will find our source code. You will find our official builds for numerous distros. Or if you want to try out our commercial product at ngix.com, it's a simple name and email address, and we'll send you a link to a 30-day trial. Now, beyond the installation, what people often find surprising and delightful about NGINX is the simplicity of the configuration, especially compared to what it might be used to. It's a C-like syntax, and it's as efficient in its configuration as the code is in its implementation. So to configure simple use cases like reverse proxy or even caching, to enable caching in front of a web server once you've got a basic configuration set up is no more than 3 additional lines, provided you've got some disk space available to run the cache. These things tend to be very easy to set up, and what otherwise might be considered quite a complex use case.
Makes sense.
There's also an enormous wealth of configuration advice, examples, blog posts, not only on NGINX.com, but also across the community. It's very easy to find a solution to the problem that you're trying to solve, and typically you'll find a config snippet of 10, 20 lines to get the job done.
Cool. So are there types of customers or apps, you mentioned microservices and Docker, that should be looking at you guys today? So, if somebody's out there listening and they're like, a certain type of business or offering that they, NGINX is something they should be having right now? Is there a perfect use case for it? Does that question make sense?
Yes, and yeah, absolutely. I'm just trying to say how many times I can say yes to that answer. I'll circle around a little bit, I guess. So I'll come back and touch on microservices, and because that is a great fit for us. But I'll also mention the legacy application. If you have a legacy app which is struggling to scale, which is consuming a lot of resources, which is crashing because it's eating up too much memory. It is frankly incredible the first time you see it. You put NGINX in front of that application, and you're adding a hop. And some people are, I'm adding a hop, it's going to add latency. But what actually happens is the application gets an easier life because NGINX is soaking up. It's like a shock absorber. It soaks up all of the requests that come in, and what the application sees is a very well-behaved client, just one very well-behaved client. And that means that it doesn't have to waste time waiting for connections to arrive. It just gets everything in one go. And we've had customers, large-scale customers, who've had a crashing website. We put NGINX in front of it, and all of a sudden it doesn't crash anymore. And in fact, it's using half the memory it used to. So that problematic, troublesome legacy app is a real great fit, and it's partly why NGINX was created in the first place. So I'd say, for one, that's a great use case for us. Secondly, microservices. Now, we've been involved in helping customers move to microservices for at least 2 years now, and in fact, we've developed 3 reference architectures for microservices to help customers on that journey. And the interesting thing is often a microservices journey is not about building something new and shiny using the latest architectural model. It's about taking that problematic legacy application and finding the bit that doesn't scale, slicing that off and building that as a microservice, and slowly over time, carving more and more off that monolith and building out a microservices implementation that works and can scale. And in some cases, that might mean leaving that core business logic in that legacy monolith, because that bit's fine. It's the database, or it's the login process, or it's handling too many different concurrent connections, which is the problem. So regardless of all that, when it comes to microservices, NGINX can fit in a number of different use cases. Now, it works really nicely as a router. So being a consistent, reliable front end for all the requests, and then having the logic the configuration to send the request for microservice A over to instance A, microservice B over to instance B. And then, of course, you need to scale out. You need to have multiple instances of each microservice. So having things like health checks, having things like session persistence, and a bunch of other features helps those applications to scale, and it helps the microservices and NGINX to know which microservices are available. And when you've got a dynamic environment where you've got containers and you don't have server names anymore, you've just got new containers popping up, being able to respond to that dynamic environment and automatically be aware of what containers are running which service, and then sending requests to the service which is responding the quickest right now, that makes the difference between a microservice application which runs sweetly and one which is problematic.
That's great. Those 3 documents you mentioned, can you guys send me those links, and I'll include them in the show notes? That sounds like some good reading for the listeners and for myself, for that matter. So I would love to get the links to those, and we'll share those along. So guys, that what Liam just mentioned, we'll check out the show notes. We'll have those in there for you, and of course other resources to learn more about what these guys are doing. Are there any types of web apps that just do not work? Are there some that you just this is not a fit for?
I have yet to come across one.
Oh, that's great.
So there's even if the original app is running on NGINX, adding things like that can be improved in terms of its reliability by having more than one of them, and therefore you need a front end which can balance the load, or just be there to manage that active-passive environment. So even if you have even if performance is not your problem, availability generally is the next thing that you're worried about, and we can always help that.
Perfect. Is there anything required to do to the application to make it work with you guys? I don't believe so. It just sits on there and interfaces with NGINX, and off we go, right?
Yeah, absolutely right. So you need to make no changes are required to the application, and in fact, that in itself allows NGINX to add capabilities to the application that it didn't have before, or to enable new use cases that it couldn't have before. So you want to enable HTTP2 on your backend application that that no one knows how to change anymore. Well, get NGINX in front, have it listen with HTTP2, and that's done. You've now got an application which can accept HTTP to clients. SSL termination is a more traditional and common use case for that. But just to give you an example of how you can enrich an application with additional functionality or capabilities it didn't have before by adding NGINX. So yeah, you need to do nothing. And in many cases, and this is very true for microservices, having a reliable front end that takes care of all the common tasks, that takes care of the crypto regarding SSL termination, that takes care of authentication, whether it's based on client certificates, whether it's based on OAuth or something else. Centralizing those means that you need to do less in each microservice, and microservice can just focus on its bit of business logic, what it needs to do. So, in fact, it actually works the other way. Rather than having to change backend application, your backend application can now do more than it could before by putting NGINX in front.
Very cool. So you talked a bit about what's new. Is there anything else that's new you'd like to point out? And at the same time, the future. What can we expect from you guys in the future? Where are you going with this product?
So we've got our annual user conference coming up in less than a month now, beginning of September. And there will be some exciting product announcements going on there, which I can't get into right now, but that's definitely something to look out for in a few weeks. Beyond that, you're going to see us putting more effort into our engine script solution. So this is allows for programmatic use cases for NGINX by writing JavaScript code. So there are a few existing programmatic solutions available today through Perl, through Lua. JavaScript, we think, is a great fit for the skill set of the DevOps engineer, and is a lot closer to the syntax and the style of how you write NGINX configuration. So you'll be able to do some real cool stuff with that, by having JavaScript code inspect, analyze, do whatever you want to do with requests as they come in and out of the systems. That's a great, we're investing a lot in that. And also kind of reflecting what I've been hearing from customers and seeing in the market is that identity and authentication is becoming more and more pervasive throughout IT, but also throughout web applications. And we see the rise of protocols like SAML and OAuth helping drive a secure single sign-on environment, and not only secure, but one which doesn't get in the way of the end user. And so you'll see more solutions from NGINX that help with managing these kinds of things in terms of identity being a core part of all web requests. So that's something which you'll see a further investment from us.
Very cool, very cool, Liam. This is neat stuff. I love what you guys do, and I have it. My website's front ended by what you guys, the NGINX engine, and it's phenomenal. I saw a reduce in database hits and an increase in speed, and I didn't do anything more than turn it on, and I absolutely love it. And if it does that for my little app, I can imagine what it does for the big boy apps out there. And it's just a great thing of what you guys bring to market. So I think that's all the questions I have for you. If there's anything else we left out or anything, if somebody wants to learn more, this is your chance to share that with us.
So I think I've spoken probably more than I need to, but if there's one of the best resources is NGINX.com. Our blog has all manner of real technical how-to guides on enabling common use cases or showing how certain features work in a way which you might not have expected, but in a way which helps you understand how you can apply that to your own site and your own application. So I would encourage listeners to check out NGINX.com, search the blog for whatever's on your mind, and hopefully you'll find some good information there.
Absolutely, absolutely. On that note, buddy, thank you so much for taking the time to be with us today. I've enjoyed this, and I've learned a lot, and I look forward to learning more about you guys. And like I said, I use it. So, this is something very close to my heart. It definitely changed how DABCC was running, which was a great, great thing. So on that note, thanks again.
Well, that's great to hear. Doug, thanks. It's been a pleasure speaking to you.
Okay, so that concludes. If I could spit that word out, that concludes another episode of the ABCC Radio. I'll leave that bit in there, so I won't edit that piece out. Sometimes I can't get words out of my mouth. You guys know this if you listen. So sometimes words and me don't go hand in hand. But I think I understand what everybody's saying, or if not, I learn more. And hopefully this is a resource for you guys to learn more, to introduce you to these great technologies that are out there and have you say, yes, this sounds like something I'm interested in, or gee, this solves my problem. I want to learn more. And that's what we're trying to provide you guys. So I hope we do that. And on that note, as always, I want to thank my guest for today, Liam from NGINX, and great solution. I touched on it from my use case, the website, the WordPress website from a hosting company that provides me, their solution as an offering, right? But it's much more than that. And, it's huge. It's huge for the new world of web applications. So web services, microservices, Docker, things of that nature. So definitely look at what they're doing from that. Docker's all the rage, and everyone's looking at how can we deploy this, how can we benefit from it. And I think that in the future, everything's going to be a microservice. Everything's going to be in a container, and these guys have a great play there. So definitely check that out. and hit the show notes for the documents we talked about. Good reading, if nothing else. Well, great reading, and for sure something else. So on that note, guys, thanks again for listening. If you enjoyed the show, please tell a friend. That's how we grow. Head over to www.dabcc.com for the latest cloud virtualization, mobility, security, AI, IoT, storage, desktop, you name it, news and support. IT news and support is what we call it. So anything relating to the IT world, I think we're posting, and so it's a great way to stay up to date on what's new and what's coming and all that jazz. So with no further ado, I just want to again thank you guys for listening to DABCC Radio.
Can you say DABCC?
DABC.
Say it again, DABCC.
DABC.
Can you say it again, DABCC?
DABC.
How about DABCC?
DABC.
DABCC.
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 DABCC.